Hi everyone, welcome back to the channel. In today's video, we'll cover the most important electrical engineering and electrician job interview questions and answers, specially designed for freshers and beginners. First question, tell me something about yourself? What the interviewer expects. A brief, confident introduction summarizing your background, education, skills, and motivation for applying, ideally connecting your electrical engineering background to your interest in software. Answer. I am a recent B.Tech graduate in electrical engineering, where I developed a strong foundation in core engineering concepts and problem solving. During my studies, I became interested in programming through automation and embedded system projects, which led me to pursue software development. I enjoy learning new technologies and am eager to apply my analytical skills and engineering mindset to a software development role. Can you describe a project or practical assignment you completed during your studies? What the interviewer expects. Ability to explain a project clearly. Focus on your role, what you learned, and problem-solving skills. If you have a coding-related mini-project, even better. Answer. During my final year, I worked on a project titled Smart Energy Monitoring System. It involved designing a system to track electricity consumption using sensors and microcontrollers. I handled the programming part using embedded C. This experience not only strengthened my technical skills but also taught me the importance of writing clean, logical code, which eventually made me more curious about software development. That's when I started learning full-fledged programming beyond hardware. What is electricity? What interviewers expect? Interviewers are looking for a clear and concise definition of electricity, as well as an understanding of its fundamental concepts. Sample answer. Electricity is a form of energy resulting from the movement of charged particles, typically electrons. It can be generated through various means, such as chemical reactions in batteries, electromagnetic induction in generators, or solar energy in photovoltaic cells. Electricity is essential for powering devices and systems in our daily lives, from household appliances to industrial machinery. What is current and how is it measured? What the interviewer expects. A precise definition of electric current, its unit, and an explanation of how it is measured. The answer should show you understand both the concept and practical measurement. Answer. Current is the rate at which electric charge flows through a conductor. It is measured in amperes, where 1 ampere equals 1 coulomb of charge passing a point per second. To measure current, we use an instrument called an ammeter, which is connected in series with the circuit so that the entire current flows through it. What is difference between current and power? What the interviewer expects. A clear distinction between the two terms, including their definitions, units, and how they relate to each other in an electrical circuit. Answer. Current is the flow of electric charge in a circuit, measured in amperes. Power, on the other hand, is the rate at which electrical energy is transferred or converted, measured in watts. In a circuit, power is calculated as the product of current and voltage. So, while current tells us how many charges are moving, power tells us how much work is being done or how much energy is being used per second. Summary table, current versus power. What is the difference between AC and DC? What the interviewer expects. A clear, concise comparison highlighting the main differences in definition, waveform, and application. Unique sample answer. AC, or alternating current, is a type of electric current that periodically reverses direction, typically represented by a sine wave. DC, or direct current, flows in a single direction and has a constant value. AC is commonly used for power transmission in homes and industries, while DC is often used in batteries and electronic devices. How do you identify whether a supply is AC or DC in a practical situation? What interviewers expect. Interviewers want to see if you can apply theoretical knowledge to practical scenarios. Sample answer. To identify whether a supply is AC or DC, I would use a multimeter. First, I would set the multimeter to measure voltage. If the reading fluctuates and shows a sinusoidal waveform on an oscilloscope, it indicates AC. If the reading is stable and constant, it indicates DC. Additionally, I could check the power source. For example, wall outlets typically provide AC, while batteries provide DC. What is voltage? What interviewers expect. Interviewers want a clear definition of voltage and its significance in electrical systems. Answer. Voltage is the electrical potential difference between 2 points. It's like the force that pushes electric charges through a conductor. It's measured in volts. We can think of it like the pressure in water pipes. Higher pressure moves more water, just like higher voltage moves more current. What is a short circuit? What the interviewer expects. Understanding of the concept, its cause, and its risk. Answer. A short circuit occurs when there is a direct, low-resistance connection between 2 points in an electric circuit, bypassing the intended load. This causes excessive current flow, which can damage equipment or cause hazards like fire. What is an overload condition? What the interviewer expects. Knowledge of what causes overload and its effects on the circuit. Answer. An overload condition happens when the electrical current in a circuit exceeds the circuit's rated capacity. This can cause overheating, damage to equipment, or tripping of protective devices like circuit breakers. What are the basic components of a DC motor? What interviewers expect. Interviewers want to see if you can identify and explain the key components of a DC motor. Sample answer. A DC motor typically consists of several key components. The stator, which provides a magnetic field. The rotor, which is the rotating part of the motor. The commutator, which reverses the direction of current flow in the rotor windings. And brushes, which maintain electrical contact with the commutator. The interaction between the magnetic field from the stator and the current flowing through the rotor creates torque, causing the rotor to spin and produce mechanical motion. Explain the principle behind how an electric generator works. What the interviewer expects. Basic principle. Mention magnetic field, mechanical energy to electrical energy. Answer. An electric generator works on the principle of electromagnetic induction. When a conductor moves in a magnetic field, it generates electricity. In simple words, it converts mechanical energy, like rotation, into electrical energy. What are the color codes used in wiring? What interviewers expect. Interviewers want to assess your knowledge of electrical safety and wiring standard. Answer. The color codes used in wiring can vary by country, but in many places, the following standard is commonly used. Black or red, live wire. White or gray, neutral wire. Green or bare copper, ground wire. In some regions, blue may also be used for neutral and brown for live. It's essential to follow these color codes to ensure safety and proper functioning of electrical systems. Color codes vary by region and voltage. Notes. The new standard colors follow IEC norms and are recommended for new installations. Earth wire is always green or green with a yellow stripe for safety. How do you check if a wire is live without a tester? What interviewers expect. Interviewers want to see if you can apply practical knowledge and safety measures in real-world situations. Answer. It is extremely dangerous and not recommended to check if a wire is live without a proper electrical tester. Electricity is invisible, and there are no safe visual method. Always use a calibrated voltage tester or multimeter. Attempting makeshift methods can lead to severe electric shock. Safety is paramount. Use the right tools. Screwdriver tester. Touch the metal tip to the wire. A neon lamp in the handle lights up if live. Light bulb method. Connect a bulb between the wire and ground. Illumination indicates live current. Non-contact voltage detector. Alerts via light sound when near live wires without direct contact. What are the basic tools that every electrician should have in their toolkit? What interviewers expect. Interviewers want to know if you are familiar with the essential tools used in electrical work. Sample answer. Every electrician should have a well-equipped toolkit that includes mustimeter, for measuring voltage, current, and resistance. Wire strippers, for removing insulation from wires. Screwdrivers, a set of both flathead and Phillips screwdrivers. Pliers, needle nose and lineman's pliers for gripping and cutting wires. Tape measure, for accurate measurement. Level, to ensure installations are straight. Electrical tape, for insulating and securing connections. Safety gear, such as gloves and safety glasses. Having the right tools is crucial for efficiency and safety in electrical work. What is Ohm's law and how is it applied in real circuits? What interviewers expect. Interviewers want to see if you understand the relationship between voltage, current, and resistance. Answer. Ohm's law states that the current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance. Mathematically, V equals IR. In real life, we use Ohm's law to calculate the resistance needed for circuits, like choosing the correct resistor in an LED circuit to prevent it from burning out. What do you do if the MCB keeps tripping repeatedly? What interviewers expect. Interviewers want to assess your problem-solving skills and understanding of electrical safety. Answer. If the miniature circuit breaker keeps tripping, it indicates that there is an issue in the circuit, such as an overload, a short circuit, or a ground fault. First, ensure safety and don't keep resetting. Then, identify the affected circuit and unplug all appliances. Try resetting. If it holds, reconnect appliances one by one to find the faulty one. If it trips immediately, suspect a short circuit, call a qualified electrician. Overloading the circuit with too many devices can also cause this. How do you use a multimeter to measure voltage and continuity? What interviewers expect? Interviewers want to see if you understand how to operate a multimeter and the safety precautions involved. Sample answer. To measure voltage with a multimeter, I first set the multimeter to the appropriate voltage setting. Then, I connect the black probe to the COM terminal and the red probe to the VMA terminal. I place the probes across the component or section of the circuit where I want to measure the voltage, ensuring I do not touch the metal parts. The display will show the voltage reading. To measure continuity, I switch the multimeter to the continuity setting, which usually has a diode symbol. I again connect the probes as before and touch them to the 2 points in the circuit I want to test. If there is continuity, the multimeter will beep or show a low resistance value, indicating that the circuit is complete. What is the purpose of a transformer, and how does it work? What interviewers expect? Interviewers want to assess your understanding of transformers and their applications in electrical systems. Answer. A transformer is used to step up or step down AC voltage levels in power transmission and distribution. It works on the principle of electromagnetic induction. An alternating current in the primary coil creates a changing magnetic field, which induces a voltage in the secondary coil. The voltage ratio between primary and secondary depends on the ratio of turns in the coils, allowing efficient voltage transformation without changing frequency. What is the difference between a single-phase and a three-phase system? And where are they typically used? What interviewers expect? Interviewers want to see if you can explain the differences in terms of operation, efficiency, and applications. Sample answer. A single-phase system consists of one alternating current waveform, while a three-phase system has three AC waveforms that are 120 degrees out of phase with each other. Single-phase systems are typically used in residential applications, such as powering household appliances and lighting. They are simpler and less expensive to install but can be less efficient for high-power applications. In contrast, three-phase systems are used in industrial and commercial settings where large amounts of power are required, such as in motors and heavy machinery. Three-phase systems provide a more constant power supply, reduce the size of conductors needed, and improve efficiency, making them ideal for high-demand applications. What is a resistor, and what is its function in a circuit? What the interviewer expects. Interviewers want to know if you understand the role of resistors in electrical circuit. Answer. A resistor is a component that limits the flow of electrical current in a circuit. Its main function is to protect sensitive components by controlling the current and to divide voltages where needed. For example, in a LED circuit, a resistor prevents the LED from burning out. What is inductance, and what circuit element exhibits this property significantly? What the interviewer expects. Interviewers want to assess your understanding of inductance and its applications in circuit. Answer. Inductance is the property of a circuit where a change in current produces a voltage across the element, opposing that change. An inductor, usually a coil of wire, is the component that shows inductance significantly. Can you explain what a capacitor does and give an example of its application? What the interviewer expects. Interviewers want to see if you understand the function of capacitors and their practical uses. Answer. A capacitor stores electrical energy in an electric field and releases it when needed. It's mainly used for filtering and smoothing signals in circuit. For example, in a power supply, capacitors are used to remove voltage fluctuations and provide a steady output. What is a fuse and where is it used? What interviewers expect. Interviewers want to assess your understanding of fuses, their purpose, and typical applications. Sample answer. A fuse is a safety device that protects electrical circuits from overcurrent conditions. It consists of a metal wire or strip that melts when the current exceeds a certain level, breaking the circuit and preventing damage to electrical components or potential fire hazards. Fuses are commonly used in household electrical systems, appliances, and automotive applications to safeguard against short circuits and overload. They are a simple and effective way to ensure safety in electrical installations. What is earthing and why is it important? What interviewers expect. Interviewers want to know if you understand the concept of earthing and its significance in electrical safety. Answer. Earthing is the process of connecting electrical equipment or systems to the earth through a low-resistance path. This connection allows fault currents or leakage currents to safely flow into the ground, preventing electric shocks, fires, and equipment damage. Earthing stabilizes voltage levels in the system, protects human life and electrical devices, and ensures proper operation of protective devices like circuit breakers and fuses. What is the function of an MCB? What interviewers expect? Interviewers want to see if you understand the role of miniature circuit breakers in electrical systems. Sample answer. An MCB, or miniature circuit breaker, is an automatic switch that protects electrical circuits from overloads and short circuits. Its primary function is to detect excessive current flow and automatically disconnect the circuit to prevent damage to wiring and connected devices. Unlike fuses, which need to be replaced after they blow, MCBs can be reset after tripping, making them more convenient for use in residential and commercial electrical systems. MCBs enhance safety and reliability in electrical installations. What is a circuit breaker and how is it different from a fuse? What the interviewer expects. Interviewers want to assess your understanding of circuit breakers and how they compare to fuses. Answer. A circuit breaker is an automatic electrical switch designed to protect an electrical circuit from damage caused by overload or short circuit. The main difference from a fuse is that a fuse needs to be replaced once it blows, but a circuit breaker can be reset manually after clearing the fault. How would you check for a fault in a simple electrical circuit? What the interviewer expects. Logical step-by-step troubleshooting approach. Answer. To check for faults, turn off the power supply. Visually inspect wiring and components for damage or loose connections. Use a multimeter to test continuity and resistance of wires and components. Check for short circuits or open circuits by measuring voltage and current at different points. Isolate sections of the circuit to narrow down the faulty part. Explain the working and importance of an earth leakage circuit breaker. What interviewers expect. Interviewers want to assess your understanding of ELCBs and their role in electrical safety. Answer. An earth leakage circuit breaker detects leakage currents flowing to the ground due to insulation faults or accidental contact. It monitors the difference between current flowing in the live and neutral wires. If a leakage current above a threshold is detected, it quickly disconnects the power supply to prevent electric shocks and fire hazard. ELCBs are crucial for protecting people from electric shocks and enhancing electrical safety in residential and industrial installations. How do you deal with a power outage in one room only? What the interviewer expects. Logical troubleshooting steps. Awareness of safety and checking basics first. Answer. To handle a power outage in just one room, first check if the circuit breaker or MCB for that room has tripped and reset it if necessary. Inspect for any blown fuses or loose wiring connections in the room circuit. Also, verify if any appliances or devices are causing an overload or short circuit by unplugging them. If no obvious issue is found, use a multimeter to test voltage at outlets and switches. If the problem persists, call a qualified electrician to diagnose and fix wiring faults safely. Briefly explain the difference between active power, reactive power, and apparent power in an AC circuit. What the interviewer expects. Very basic one-line explanation for each term. Sample answer. In an AC circuit, the differences between active power, reactive power, and apparent power are as follows. Active power. Measured in watts, this is the power that actually performs work in the circuit, such as lighting a bulb or running a motor. Reactive power. Measured in volt-amperes reactive, this power does not perform any useful work but is necessary for maintaining the electric and magnetic fields in inductors and capacitors. Apparent power. Measured in volt-amperes, this is the total power in the circuit, combining both active and reactive power. It represents the product of the RMS voltage and current in the circuit. Why are you shifting from electrical engineering to software development? What interviewers expect. Interviewers want to understand your motivation for the shift, your passion for software development, and how your background in electrical engineering can be an asset in the software field. Sample answer. While studying electrical engineering, I developed a strong interest in programming and software development, particularly in how software can control and optimize electrical systems. I realized that software is becoming increasingly integral to the engineering field, especially with the rise of IoT and smart devices. I have taken several programming courses and worked on projects that combined both fields, which solidified my desire to transition into software development. I believe my engineering background gives me a unique perspective on problem solving and system design, which will be beneficial in a software role. Have you worked on any programming or software projects during college? What the interviewer expects. Mention any experience, show genuine effort to learn. Answer. Yes, during college, I worked on several projects involving programming. For example, I developed an embedded system project using Arduino to automate home appliances, which involved C++ programming. I also completed coursework in data structures and algorithms and built small applications in Python and Java. These experiences strengthened my coding skills and interest in software development.